Okay, in this construction, we're going to draw a regular hexagon. It's a six-sided polygon. And the key here is it's a regular hexagon, which means each of the sides, and of course each of the interior angles, must be the same. Here you can see a six-sided polygon, but it's not a regular hexagon because these sides are clearly not the same. Okay, so the question is how do we do that with just a compass and a straight edge? Well, the thing to remember is what is a regular polygon? And if you remember, looking at some of these notes here, a regular polygon, again, has each interior angle the same. And the way you can measure each interior angle is by this formula. And basically what it is you take the number of sides n, subtract 2 times 180, you get divided by n. So in the case of a hexagon, if you have 6 sides, 4 times 180 divided by 6 is each interior angle is going to be 120. Another way to look at it too, by the way, is take all the exterior angles, in which case there are 6 of them. 360 divided by the 6 is 60 degrees. So of course, if you've done a few constructions, as soon as you see 60 degrees, you think, this might be an approach I can take, which is what we're going to do. We're going to basically assume that if we can draw a line and draw some equilateral triangles, because these are all 60, 60, and 60, and do that a couple times, we've got ourselves the bottom half of our hexagon. And then we simply have to do the top half, in which case we'll have 120 degrees, 120 degrees, etc., etc. Okay, so let's get started. I think we'll first start is let's draw the base of our hexagon. Okay, we're going to make it extra long. And what we're going to have to do is we're going to have to draw a couple equilateral triangles. And of course the key is all the sides have got to be the same distance, length. So what we'll do is we're going to establish that from the start. So let's take our pen so you can see. This is going to be the length of each side of the hexagon. Okay? And so what we're going to do now is we're going to simply take our compass and measure the length, this point, and we'll get it exact. Okay? This is the length going to be of each side. So our next thing we're going to do is let's start drawing some equilateral triangles on each side of this side. By the way, this is going to be the bottom of the hexagon. This is side 1. Okay? So we keep the same length, draw an arc up here. Okay? And of course the bottom of our equilateral triangle will of course have the same length. And then we go to the other endpoint, which is the other vertex. Draw an arc up there. Okay? And then we simply draw the sides of our equilateral triangle. Okay, we'll make it light because this is the other side. And make this one dark. Okay? So this is 60 degrees, this is 60 degrees, and this is 60 degrees. But more importantly, this is 120 degrees, which of course is the measure of each of the interior angles of the hexagon. So again, let's do it again for the other equilateral triangle. Again, we'll draw an arc. We're keeping the same length all the way. And then from this end point, which is the vertex of our equilateral triangle, we'll draw an arc up here. And then go back to our point and draw an arc. They just intersect. Probably should have drawn longer arcs. But we got an intersection. And from this arc intersection, we will draw back to our point. Okay. And this point. Okay. So there you have it. Here's 1, 2, 3 sides of our hexagon. And this is 120 degrees. This is 120 degrees because supplementary angles add up to 180. And now what we have to do is we have to repeat the same process. Now there's a couple ways to do that, but I'm going to take the most direct approach, okay, which of course what I think it is. And that is if I can draw a perpendicular line all the way up and all the way up, these will enable us to draw a connection this way and form the top half. And as I diagram it, you'll see kind of what I mean. Okay, so let's draw a perpendicular bisector, perpendicular line through this point. So we draw an arc over here and an arc on the other side. And of course from these endpoints, we draw an arc above and an arc below. Okay, and then from the other endpoint, we draw an arc above. Again, I just got it to clear. And an arc below, that one's a better section. Okay, and then what we do is you take our straight edge and draw a line through these points. We'll draw it lightly. Okay, and note, this is 60 degrees, so this is going to be 30 degrees. Okay, and of course, if we draw one up here, this will be 30 degrees, which means 30, 30, and then this will have to be 120. Okay, so let's do the same thing for the other side. Again, we take our point. Okay, this is the center of where the perpendicular line is going to go through. We draw an arc of length that way, arc of length that way. Okay, and these are the endpoints of our bisecting perpendicular bisector. So there's an arc above and an arc below. And then on the other side, from this endpoint, we shall do an arc above and an arc below. And again, we take our straight edge, we draw a perpendicular line, okay, through, like so. Okay, so again, this is 90 degrees, this is 90 degrees. More importantly though, this is 30, and this is 30. Now, what do we do now is we go back to our original length of each side of the hexagon, okay, which is this point, okay. Oops. We draw, and of course it's the same for all of them. No, it goes through here too. And we do the same thing. Let's just extend the sides. Here's another side of the hexagon, like that. And then we do it on the other side. Here's another side of our hexagon, okay. And just a confirmation, look at how the distance is the same. Okay, and then let's just connect all these points. Okay, here's 1. Okay, and here is 2. Okay, and then here is 3rd. And there you have it. And here's our this is our original point, bottom here. And there you have it. 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. They're all congruent lengths because our compass determined the length. Okay, and then if you notice, each interior angle is 120 degrees. In this case, this one is 30 degrees plus 90. This is 30 plus 90. This is 30 and 30, therefore this is 120. And you can go around and verify the entire part of this regular hexagon.